Now let's have a look at how we will interpret the Probit estimates. That is, once we have run a grouped Probit model and we get the results, how do we interpret them? Well, the main thing that we always want to find out would be the effect of unit change in X how does it impact the probability that y will be equal to 1. So in the example that we have been continuing throughout this lecture, we want to know how a unit change in X, that is the income of the family, would change or affect the probability that the family will own the house that they live in. We know that the probability Pi in our Probit model is a function of, it's a capital F to denote that this is a cumulative distributive function. It's a function of our index II, where II is equal to beta 1 plus beta 2 xi. Therefore, what we want to find out is how does my probability of owning a house change with a small change in the value of the income. So we want to know dpi by dxi, and that would be the differentiation of a cumulative distributive function will give me small f of beta 1 plus beta 2 xi, where small f denotes the probability distribution function. Remember, it is when you integrate the probability distribution function, the PDF of a statistical distribution, that you will get the cumulative distribution function. So if I differentiate the cumulative distribution function, I should get back the probability distribution function into, since this is chain rule that I am applying, differentiation of beta 2 xi with respect to xi will give me beta 2. So remember, I am using the chain rule, and also remember that capital F represents the cumulative distribution function of any probability distribution, and small f represents the probability distribution function, or the probability density function. That is the more appropriate term, the probability density function of the variables distribution. So this would be the formula that we'd have to use to find or estimate the change in probability of owning the house due to a unit or due to a small change in the income of the family. Once you have run the regression, the values of beta 1 and beta 2 you can get directly from the output table. And for xi, for example, say the value family income is equal to 6, and in this example that is there in the book, it is in thousands of dollars. And if you want to know at this income level, how will a small change, a unit change in incomes affect the probability of owning a house, you can always estimate that by putting down the values of beta 1 and beta 2 from the regression results. The value of beta 1 in the example is 1.0166. The value of beta 2 from the regression results is 0.04846 times xi, which is 6, and the value of beta 2, like I said, is 0.04846. Now, This adds up to be minus 0.72548 into beta 2, which is 0.04846. Now, to read this, remember the Probit or the Normit model follows the standard normal distribution function. So you can always refer to the normal distribution tables and find out, read from the table f of z, which is nothing but the probability that where your z is equal to minus 0.72548. This value can be read off from the table. And the value comes out to be approximately f of 0.72548. When you have a look at the normal density table, normal distribution table, it comes out to be around 0.3066 into beta 2 comes up to the value of 0.01485. So what this means is, at an income level of x equal to $6,000, since the units of this table is in thousands of dollars, you will interpret this as saying at income levels of $6,000, family income levels of around $6,000, a unit change in income, that is, if the income goes up by 1 unit, which means the income goes up by $1,000, the probability in favor of owning the house where you live in will go up by 1.49%. So this is how you would compare and interpret the results of a Probit estimate. In the next slide, I'm just putting a snapshot of the regression result based on which I have done this calculation. Over here you can see the values that I have used are from this output table over here, where this is my beta 1 and 0.0486 is the value of beta 2. Conclude this section by actually discussing once more with you the marginal effect of a unit change in the explanatory variable or the regressor in the different regressor models that we had a look at. The first model that we looked at is the linear probability model. Remember, this model is not so important in terms of the syllabus, but it is important that you understand this because it is in comparison to the LPM model that we show that a logit or a Probit model is more sensible or might in many cases be the better and more sensible alternative. So in the LPM or the linear probability model, the slope coefficient, that is beta 2 in a 2 variable model, or if it's an xi, maybe beta I, this coefficient of this regressor directly measures change in probability of an event occurring or of y being equal to 1 due to a unit change in the value of the regressor, all other things remaining constant. So I'm going to write it as ceteris paribus. So this is the marginal effect of the change in value of xi given all other explanatory variables or regressors are remaining constant. In the case of a logit model, the slope coefficient actually gives a change in the log of odds in favor of the y variable being equal to 1 due to a unit change log odds ratio in favor of yi being equal to 1 due to a unit change in the value of the regressor, again all holding all other variables constant. So ceteris paribus is implied. If you want to have a look at the change in the probability of the event, change in the probability of the event happening, that is, if you want to have a look at change in the probability due to a unit change in the regressor, you will have to use the formula beta j times pi into 1 minus pi. Here beta j denotes the partial regression coefficient of the jth regressor. So I'm saying that in terms of a general k factor or k variable model. In the Probit model, the slope coefficient is a little bit more involved. In the Probit model, the rate of change of probability given a unit change in xi will be given by beta j times f of zi, where beta j again is the coefficient of the partial regression coefficient of the jth regressor, and f of zi is the density standard normal probability density function, where zi is equal to beta 1 plus beta 2 x 2I and so on, depending on how many variables you have. So if I write it in general terms again, I can write it as where zi is equal to beta 1 plus beta 2 x 2I plus beta 3 x 3I, etc. beta k x ki. So this will bring to an end our discussion on different qualitative response regression models, that is regression models where your dependent y variable is a categorical variable. Please do note that we have only discussed cases where the dependent variable is dichotomous or takes on two possible values. There are more econometrically evolved and involved models that can handle y variables that have more than two categories. The example that I had given at the very beginning of this qualitative response regression models was choice of mode of transport. If you are choosing between public transport versus private transport versus something like an auto rickshaw in traveling to your destination. As far as the syllabus is concerned, we only need to cover the logit and the Probit model. I covered the LPM just so that you have a standard to compare the other logit and Probit models to. So with this we can wind up our discussion on qualitative response regression models. Thank you, and if you have any doubts, please do get back to me.